Good morning. We are getting ready to start lesson 31. This is the last lesson of this module. It is a one-day lesson. Please watch the Eureka video before you start things for these word problems, and do remember to use cubes and read, draw, and write for each of the problems. So today you are going to be solving the following word problems by drawing a tape diagram. Sometimes we refer to that as a bar diagram as well. And you can use any strategy that you have learned, to solve those problems. So we've been talking about a lot of different strategies over the last couple of days, and you may use any of the addition or subtraction strategies that we have talked about over the course of Module 4. So you're going to do problem number 1 and problem number 2. Some of these are two-step problems, and you're going to need to pay attention to which ones are. So you've got problem 2, part A and part B. Then you have problem number 3, a part A and a part B. Then you have problem number 4. You need to read that one very carefully because you just need to read it carefully. Then you're going to come back and let me go over the problems with you so you can see how you did on these problem set problems. And then of course you're going to do problem 1 and 1A and 1B as a part of your exit ticket, and also part C, or not part C, but part 2. So there's actually 3 things that you need to do for your exit ticket, and of course then you're going to send that to your teacher. So make sure you read the word problems by drawing a tape diagram. Sometimes I know that I do refer to this as a bar model. And same thing, just 2 ways to say the same thing. Then use any strategy that you've learned in Module 4 to be able to solve those problems. Alrighty, so I'm going to go back to the beginning. I'm going to tell you to go and watch the video. Then you need to come back, work these problems, pause the video, and then come back and check with me to see how you did on these word problems. So with that, I'm going to tell you to go take care of watching the video and then working these problems, and then coming back and you can check your answers with me. Okay, we'll see you in a few minutes. Are you back? Alrighty, here we go. So let's take a look and see how you did. Solve the following word problems by drawing a tape diagram, or also they are called a bar model. I think I probably call it that more often than I do a tape diagram, but they're the same thing. Remember, you could use any strategy that you've learned in Module 4 to be able to solve these problems. So I'm going to start by reading the problem and doing cubes. Mr. Roberts had graded 57 tests on Friday. That's going to be an important word. And 43 tests on Saturday. Okay, so Mr. Roberts graded 57 tests on Friday. Looks like he's working on the weekends. And 43 tests on Saturday. And we're supposed to find out how many tests did Mr. Roberts grade. All right, well, let's take a look at how we might solve this. First of all, I am thinking that I need to draw myself a bar model. So here I go. Here's my bar model, or my tape diagram. And I know that he did 57 tests on Friday. He graded. And then on Saturday he did 43 tests. All right, so I'm trying to find out how many tests did he grade altogether. So this would be the total tests that he graded, total tests. Looks to me like I would probably want to, for my number sentence, I would be looking for 57 plus 43 equals the unknown. And here's what I am trying to find. All right, so I have a part and a part. Part was graded on Friday, part was graded on Saturday. If I put those 2 parts together, I will find out the whole number of tests that were graded. So for me, I really have become a huge fan of the new groups below strategy. I really like it, and so probably that's the strategy that I will be using, simply because to me it's the fastest one to do, and it's kind of like doing the chip model, with the chip model part being done in my head and the rest of it being done on pencil and paper. So if I'm going to add 57 and 43, I'm going to start in my ones. 7 ones plus 3 ones is 10 ones. I know that 10 ones, if I have 10 ones, I am going to have to compose a 10. So that tells me that I'm composing a 10, which is coming over here into my 10s, and that leaves me with 0 ones. So here I have 10 ones, or 1 10 and 0 ones. All right, so now I'm coming over into my 10s. I'm going to add 5 10s and 4 10s, which is 9 10s plus 1 more 10 gives me 10 10s. 1 more 10 gives me 10 10s. So here I am with my 10 10s, and I end up with 100. So 7 ones plus 3 ones is 10 ones. I had to compose a 10. Oh, I know one thing I should have really done on this one. 5 10s plus 4 10s is 9 10s, plus 1 more 10 gives me 10 10s, and I really should have composed another 100, which I did, because 1 100 plus 0 100s and 0 100s does give me the full 100. So I know all in total he graded 100 tests. He graded 100 tests, so I had to compose a 10. I also composed 100. So now I need to do the right part. Mr. Roberts graded, and don't forget that writing part, graded 100 tests. If you got that one correct, congratulations to you, and you should give yourself a great big huge smiley face. Hopefully you did. Now we're coming down to problem number 2. There were 54 women. There were 54 women and 17 fewer men than women on the boat. I need to find out how many men were on the boat. I'm going to read that one more time just to clarify in my head what I think I'm going to be doing. There were 54 women and 17 fewer men than women on the boat. Well, I do know, if I did myself a bar model, I do know the total number of women. The total number of women was 54. That was the total number of women. And I know that there are 17, that would be 17 fewer men than women. So 57 fewer men than women, and I am trying to find out the number of men. There I go. I've got my whole, and I'm going to take the fewer part away, so 17 fewer men than women should give me the total number of men. So that would be 54, take away 17 will give me my unknown. Now let's see, 54 take away 17. I'm going to subtract, and I am going to look at my whole and ask myself the question, can I take 7 ones away from 4 ones? I know that I can't do that, so I am going to decompose a 10. Decomposing a 10 leaves me with 4 10s. That decomposed 10 is now 10 ones. I'm going to put it over with my ones. So 10 ones plus 4 ones gives me 14 ones. And if I was using the chip model, these are exactly the steps that I would take as I decomposed a 10. And the only difference is I'm not drawing the chip model. 14 ones take away 7 ones is 7 ones, and 4 10s take away 1 10 is 3 10s. So that tells me that there is a total of 37 men on the boat. Writing it out, there are 37 men on the boat. How'd you do? Did you get that one right too? Well, if you did, congratulations. Now this was step number 1. Step number 1. I'm going to have to do a step number 2 because this time I'm being asked how many people were on the boat. Well, I know how many women were on the boat. I also know how many men were on the boat, don't I? I think I do. So that would mean if I was going to do my tape model or my bar model, I would say, well, I know that there were 54 women on the boat. 54 women. And I learned when I did the subtraction problem that there are 37 men on the boat. So if I want to find the total number of people on the boat, I think I am going to have to take 54 and add it to 37. I'm going to take my part plus my part and come up with how many people were on the boat, or the whole. Okay, that's not too tough. 54 plus 37. I'm going to use the new groups below method to add those together. And let's see, 7 ones and 4 ones. 7 ones and 4 ones are 11 ones. That means I had to compose a 10. If I was doing the chip model, I know I would be composing a 10. And I am seeing, oops, sorry about that, 11 ones represented by 1 10 and 1 1. Then I'm coming over to my tens. 5 tens and 3 tens is 8 tens, plus 1 more 10 gives me 9 tens. So I know that there is a total of 91. Oops, that was my big question mark. There are 91 people on the boat. There are 91 people on the boat. Now, if you're not getting these right, you need to go back and rethink about what you did and where you made your mistakes, because now that I'm showing you how to do it, it makes it seem a lot easier, but hopefully you get to give that big smiley face to yourself because you were able to do it all by yourself. And I will tell you that on the tests that we're going to be taking next Monday and Tuesday, there are several word problems that you are going to have to solve. All right, so now let's come over to problem number 3. Mark, here's Mark. Mark collected 27 fewer coins than Craig. Mark collected a total of 58 coins, and we are trying to find out how many coins did Craig collect. All right, so let me think for just a second here. I'm going to read that again. Mark collected 27 fewer coins than Craig. That means Craig's number is going to be bigger than Mark's number. Mark collected 50. Oh, I think I can see this. So I'm going to make my bar graph. Here we go. So this would be 27 fewer. This would be the 27 fewer. Mark has 27 fewer than Craig. And Mark, we do know that Mark collected 58 coins. Mark has 57 fewer than Craig. Okay, so Mark has 57 fewer than Craig. Mark has 58. And if I don't miss my guess, if I combined those two numbers, because I definitely have to have fewer, he has to have fewer than Craig. Craig's number is going to be bigger. And I am looking for Craig's coins. How many did he have? Craig's coins. Okay, so this is my big unknown here. All right, so that would be 27 plus 58 equals 27 plus 58 equals, well, that does not look like that's going to be too tough of a problem. So here I go. I am going to use new groups down below, or new groups below, and I am going to combine 27 and 58 to find out how many coins Craig had, because Mark had fewer coins than Craig. Mark had 58, which means this number is going to have to be larger. So 7 ones plus 8 ones is 15 ones, and I did have to compose a 10. So that 10 is coming over into my tens. I can see that I have 15 ones being represented by 1 10 and 5 ones. Now, I'm coming to my tens. 2 tens plus 5 tens is 7 tens plus 1 more 10 gives me 8 tens. So I know then that Craig had 85 coins, and that makes a lot of sense because he has to have more coins than Mark because Mark has 27 fewer than Craig. Well, that's exactly right. So that would give me an 85 there, and I would write out that Craig has 85 coins. How'd you do? Are you happy? I hope so. I hope you're getting stronger and stronger at being able to do these kinds of word problems. This was step 1, step number 1. And now part B is going to be step number 2 when we have a 2-step problem. So Mark collected, here's Mark, he collected 18 more coins than a new person, which is Sean. So Mark collected 18 more coins than Sean. How many coins did Sean collect? Well, let's see. What do I know from this problem that would help me with this problem? Do I know the total number of coins that Mark collected? Well, I think I do. I'm going to start with Mark here. Mark collected. Mark's coins were, let's see, Mark's coins up here were 58. And I know that he collected 18 more than Sean. I'm going to try to figure out what Sean is. He's my big I don't know. Sean is the big I don't know. But I do know that Mark collected 18 more than Sean. So this was Mark collected 18 more than Sean. So I think if, that's a whole, take away a part should give me the missing part, which would tell me how many coins Sean had. So 58 take away 18 is what I am trying to solve. So here I come over, 58 take away 18. And I am going to take a close look at my whole, and I can see that 8 ones take away 8 ones is 0 ones, and 5 tens take away 1 10 is 4 tens, and I did not have to decompose any tens in order to be able to get that. So I know that Sean had a total of 40 coins. So 58 take away 18 is 40, and Sean has 40 coins. Woohoo! Boy, I hope you're just having such great luck on this. Alrighty. One more to go, friends, and I'm hoping that you're just doing a smackety dab good job on these problems. Alrighty, so let's read this and find out what we're supposed to do on problem number 4. It says that we have there were 35 apples on the table. 17 of the apples were rotten and were thrown out. 9 of those apples were eaten, and now I need to know how many apples are still on the table. Well, I can already see that this is going to be a 2-step problem. Otherwise, I won't be able to get the answer. So I'm going to start with step 1. Step 1 tells me that I had 35 apples, and 17 of them were rotten and were thrown away. So if they got thrown out, that means I'm going to have to take them away from my total. All right, let's do a tape diagram of that. 35 apples is what I started with on the table. Here's my apples that are on the table. And 17 of those apples were rotten and thrown out. That will tell me how many are still left on the table right now before those 9 were eaten. So 35 take away 17 should give me my other part. My whole take away the part that were thrown out should give me the part that were still left. Apples left. Well, after we threw those rotten ones away. So 35 take away 17. I'm going to look closely at my whole and see if I can decompose a 10. Can I take 7 ones away from 5 ones? Nope, don't have enough. So that means I'm going to need to decompose a 10. I'm going to decompose that 10 and put it over into my ones. 10 ones plus 5 ones is 15 ones, and that leaves me with 2 10s after I decompose. 15 ones take away 7 ones is 8 ones, and 2 10s take away 1 10 is 1 10, which leaves me at this point, at least in step 1, with 18 apples that are still left. Now, after I found out everything I needed to know for the first step, that was this part. I'm just going to highlight that in yellow because that was part number 1 or step number 1. But I still have another part that I need to think about. After there were 18 apples left, after I threw away 17 of them, 9 of those 18 got eaten. So 18 take away 9. Oh, this is going to be so easy. 18 take away 9 should tell me how many are still left on the table for step 2. All right, let's do our bar model. Here we go. 18 apples were left after I threw some out. 18 apples. Then 9 of those apples, 9 were eaten. I need to know how many are left on the table. Left on, left on the table. How many were left on the table? Oh, this is a pretty easy problem. So I know that I am going to do my whole, take away my part. Here I go, sorry about that. My whole, take away my part. Here I go, looking at this. Can I take 9 ones away from 18 ones? Nope, I'm going to have to decompose a 10, which leaves me with 0 10s. 10 ones plus 8 ones. Oh, no matter how I look at it, I'm going to have to know what 18 take away 9 is. Well, that's one of our basic facts, and you should know that if I have in my number bond, if I have 18, 9, I know that the other half of my number bond is going to be 9. So 18 take away 9 is 9. That means that there are 9 apples left on the table. So there are 9 apples. Oh, brother, mister. There are 9. Oh, dear, that is definitely not an A. There are 9 apples left on the table. On the table. 9 apples left on the table. There we go. I hope you got a big, huge smiley face after the 2-step problem that needed to be done for problem number 4. And now the only thing left for you to do is to do problem number 1 and pay very close attention. It is a 2-step problem because they're giving you an A and a B. And problem number 2, you're going to have to think about whether or not that one's a 2-step problem because I am not going to tell you. All right, my friends, I hope you had a great day of learning, and when you're done with this, make sure that you send it to your teacher. And I will say ta-ta for now.